Good morning, class. Good afternoon. Good evening. Assalamu alaikum wa rahmatullah. It depends on from where you are joining the program. Welcome to Big Bang Data Science Solutions, the Ramadan program, week number 5, session number 2. Yesterday, we talked about the how to handle two of the most common problems with the data, and that is missing values and outliers. So we learned about the type of missing values. We learned about to look into other things that might be missing values, like the zeros, like numbers, few numbers, because most of the common methods used to take missing values, they are designed around the null or empty string. We also talked about the type of missing values. We talked about the mcar, missing completely random. Then we talked about the mnar, the mar, missing a random, and nmar, missing not a random. And we talked about a few things to do to handle these missing values. We could do listwise and column deletion. And we learned when we could delete a column or when we could delete a record. Imputation with the constant for numerical data, imputation with the with distribution or standard deviation for numerical data also. Then imputation, imputing missing values from a model using machine learning to predict the value of the missing value, especially if you have a larger missing in the data. Then, or creating a dummy variables for the categorical data if you have missing values in categorical data. Imputation for categorical data using the mode, etc. So these are a few steps or few techniques or few options that we have to handle missing values, if any. And also we talked about the outliers. Now, in the outliers, by definition, is uh, any data point or any element of your data that lives too far from the majority, at least two standard deviation. And it could be one data point, it could be a group of elements. Yeah. And we talked about the outliers and versus anomalies. And we talked about the how to handle outliers, remove outliers from the modeling or from the data, how to do that. And we talked about the how to separate that. I mean, another option to handle to deal with outliers is simply to separate outliers from the data. Create two partitions, one for the outliers and one for the mining of your data. And we could transform your data using any transformation technique like scaling, normalizing, and standardizing to squeeze all the elements, all the range of your data, so you don't see an outlier anymore. And you could bin your data if you have categorical and numerical data, and also you could leave outliers without any modification, and you could leave also the missing values without any modification, especially if you are planning to use any non-algebraic, non-probabilistic models like decision tree, random forest, or any models that uses decision tree as a base learner. So that is what we talked about yesterday. Today we are going to try to implement some of these. Of course, there is a lot of other methods that we could use, but we are going to simply use the most common ones. So please go ahead, and I shared, by the way, this document with you on Slack. I'm sorry, not on Slack, on the Canvas. And click on the Dropbox. and it's there. Yeah, assign Python codes and bank loan application data preprocessing, and you have the data set number too. Okay, I'm gonna give you 2 minutes. Simply help you download the file so you can follow up along with me while we are going through the code step by step.
Hi, yes. So my question was basically when you're looking at outliers, especially when you have a cluster of outliers that is two standard deviation, how do you differentiate that is indeed the outliers and not the the data set that we need to be looking at?
So good question. So if you have a 50-50%, let's say that both of them, they are going to be outliers to one another. So you are going to treat them both. If you have to treat one as normal, then you have to treat the other one as an outlier. So let's say that you have something like this. So we got here a group of elements. And you get here another group of elements. Okay, and if you look into them, there is an outlier in there. So this is one group, and this is another group. So which one of them is the outlier? Which one of them is the normal? Of course, always the normal is the one that closer to zero. No, it's closer to zero. That is the normal, and the other one is, the other one is the other cluster or the other elements or group is an outlier because it's too far from the main group. And how to handle this? So you have many options. We could split. So this is group A and group B and treat them accordingly. So we are going to use, let's say, machine learning A and machine learning A for both, and average or do a voting if you want to do machine learning. You could squeeze them using scaling. So when you scale, of course, the value or the range is going to be either between -1, 1. So, or it could be between 0, 1, or in some cases it could be -3, 3, or 0, 100. There's a lot of methods scaling to scale. And of course deleting is not an option. So there are two probably made, or you could leave them, leave the data as is and apply non-algebraic non-probabilistic models to handle them. Okay, Fad, clear?
Yes, thank you.
You're welcome. Okay, so the file now should be ready. So the first thing we did, number one, imported the packages, numpy, matplotlib, pandas, and then we are going to import the version number 2 of our data. So version number 2 is simply version number 1 minus some of the features that we decided to eliminate using our prior knowledge and also using our the correlation analysis. So then out of, I believe we started I don't remember how many features that we have, but yes, yeah. So well, we got few. Now we got few. We got our and most of their mining features, they are categorical. So we have to transform them, and that is the topic for next week, is how to transform categorical into numeric. So by the following week, we should have a final version that we are going to use for the modeling. Okay, so now we are going to do pre-processing, or simply data quality auditing. So the first thing we got to do here is check the outliers. I'm sorry, check the missing values using the A's, NA. And as I mentioned yesterday, this is NA only detects the null and empty cells. So unfortunately, it will not detect other type of missing values. So if you have a missing value with missing value with a 0, missing value with the -1 or -111 or 99, it will not detect this type of missing values. So what you have to do is one of the methods to help you simply detect this type of missing values is using the statistical analysis. Especially you could use a describe function. Yeah, and take a look into the features one at a time. If you see any value that does not make sense statistically, then definitely you might need to question. Yeah, you might need to question. You got some zeros in here. Previous, you got some zeros in there. So if you've seen anything that does not make sense to you statistically, the first thing you got to do before you decide, you determine what needs to be done next, is consult with your data expert and within your team, and see if they can clarify your doubt or your concerns before you proceed. So I see some zeros in there, for this previous. I see there's a zeros in there. Yes, I see some zeros in there. Campaign, yes, that is true. So I got some negative values in there. Try to clarify that. Okay, this is target variable. We don't have a target variable. Of course, it's going to be either a 0 or 1. So we are fine with that. So yes, I see some zeros in there. So go ahead and, yeah, I see another 0 in there, the minimum. I see another 0 in there. Yeah, just go ahead and clarify that with the business. Make sure that the zeros represents a true value rather than an empty or missing value. Okay, but if you have a missing value, a null or empty cell, of course this SNA will detect it. And let's take a look. Uh, let's uh, let's do that. Okay, I'm gonna open up my file. Okay, and I'm gonna take the first. I'm gonna eliminate the first feature or the first element of age. The first. Yeah, I'm gonna remove 56. Remember that it's 56. I'm gonna save my data. Just save my data, and you could do that also with any feature. But just remember what you did. And I'm gonna go back to the code, and I'm gonna reload my file. Okay, and now let's take a look into describe age. You see here, with the describe, it will give you, it does give you all the information. I know there's a missing values and it's not countable. And now if you were to run as NA, I know the age is going to return 1. Yes, you got here a 1. Okay, that was a 56. So I gave, if you were to remove this NA, so this is only so if you were to remove this one record, one record, which is only one record out of 41,000. Of course, we can remove that because it's only one record. That is one option that we have to handle these missing values. We could do drop NA. Drop NA is going to go through all your data frame and is going to look for those empty cells and remove them. So I'm going to run this. I'm going to run this drop NA, and if I were to run this one more time, the one record will disappear. It's gone now. Okay, so it's gone. Yeah, drop NA is going to go through all the empty cells in your data frame, in your data set, and eliminate them. So if you have 50% of your data that has missing values, if you want to do a drop in, it's going to remove 50%. So let's read the data one more time, and we are going to learn how to impute that one value with a mean and median. So here we go. So we got in NA none. You see that none means non-applicable or non-value. Okay, take a look into missing values. We got one. I'm not going to drop it. Okay, you could delete a column, simply uncomment. There we go. So I'll just remove the triple. Anything you see in red is a code for you guys to use as a template. But since we are not using it, I'm putting it into between two, triple quotation. So you could delete the column, simply uncomment. You could delete the row that has an NA. So we are going to do it. So this is the code. I'm going to skip. If you have let's say a question mark in there, let's say that we have a question mark. So the question mark in there, or we got a 0 in there, and you want to one way to change it, one way to handle this question mark is simply to do replace or to map it. So we could do what was this? P plays. Yeah, no, P days. Sorry. And run it, and you should be able to replace the question mark. Yeah, let's do that. Yeah, we are going to do that right now. Okay, so I'm going to read my data one more time. Okay, is in A. We still have one element in there. I'm not going to drop it. And now I am going to print out the unique of this variable p days, previous days. Then we are going to replace it. We are going to replace it. Replace the question mark with NA. Then we are going to look into. We are going to print it again. So we are going to print the unique day, the uniqueness, the unique values of a p-day value or p-day column. We are going to replace the question mark with NA. Then we are going to check if that is done. So here we go. So these are unique, but I know there is a p-day. Oh, I did not save this. So let's save this. And now I'm going to read my data one more time. There we go. And now take a look into the missing values. As you see here, it will not detect. We have a missing value in PDAs, but it's not detectable. But because we have something in the cell, that's why it's not detectable. And now, if you go to run this only, yeah, the uniqueness you are going to see. So you got 99, a question mark, and you got values. So we want to replace this question mark with NA. So the first list is we got the question mark, and the second list we got NA, means an empty. And if you were to run this, I believe we are going to get two. We are going to get another one for PDs. Let's try that. Here we go. We got previous days is one. So it does as NA is simply looks for empty cells or a cell with an NA in it. Okay, so yeah, we could. So let's say that now we can replace. We can replace I'm going to show you how to impute the missing values of age. So the missing value is what? So missing value is, I believe, 56, right? That is the missing value. Okay, so we are going to create, number one, we are going to calculate the mean. We are going to create the mean using the mean value. So we are going to do two things. We are going to create the mean, and we are going to create the median. So let's create let's calculate the median and the mean. Okay, so the median, yeah, the mean is around 41, of course, and the median is around 38. So if we were to to replace to impute the missing value, which is 56, with the mean, we are, it's going to be 40. Otherwise, it's going to be 38. Of course, this is simply an approximation, and we might not ever get the true value, but it's better to have a value in there rather than removing the column. So I am going to replace the age, the missing value of age, with its mean using the fill NA. Fill anything that is not a value, anything that is not applicable. So if I were to run this, the value of the first element, if I run that, then I'm going to run this one more time. So the value has disappeared. And now let's take a look into the head again. So we got, here we go. So we got 40. So basically this is a 56, but it was imputed using the mean or the median. And the same thing we could do with the variance, standard deviation, just calculate them and replace the missing values with whatever value you want. Questions, concerns? Okay, I see some chat questions in the chat. Say, is this file we need download? Yes. No, it's download for week number 5 in Canvas. Week number 5 Canvas. Okay. Any question?
If there are multiple missing values, it's going to do the same thing for all of them.
Yes.
Okay.
Yes, that is true. Yes, I mean, yeah, it's gonna fill out anything that is in NA. If you have 50, then all the 50 empty cells, all those empty cells will be replaced by a main or median or whatever method that you're trying to impute and fit values. Okay,
Hi, brother. One question. Why did we replace the NA values with specifically the mean, like not the median or other value?
because we have a missing values. We have something in there that does not fit. And if you were to use the data as is, of course, it is going to create a lot of problems. So we cannot. This is a GIGO, garbage in, garbage out. If you have a missing values in your data, you will build a solution that is too far from the reality. It does not represent the true meaning of your data. So we have to handle it. And one way is to impute, replace the missing values with something that you know would work. Otherwise, just eliminate, delete records with missing values.
Okay, so the first you replace all the
No,
empty.
I mean, if you were here yesterday, we talked about different methods to handle. So you could use only one of them, either eliminate, impute with the constant, with a mean or median, impute with the distribution. You could impute from the model, you could predict. You could, if you have categorical data, you could do dummy variables. You could do mode for categorical data. There is a lot of options that you have handy to handle your missing values, but don't leave the missing values unhandled.
Right, but just today, so you replace the
Yes.
empty boxes and the question marks with NAs, and then we replace the NA with the median.
Yeah, for this one, we replace this. We could do that. We could do if there is a zero in there. So there is a zero in there. So we could replace all the zeros with NA, and after that we impute that NA with the distribution or variance or mean or mode, mean or median. That is yes, that is one method. Okay, but if there is an empty there and simply an empty cell, simply go ahead and if you decide to keep them, then replace them with with them. Sorry, with impute them with the mean or mode or distribution. If you have if you have a string or a special character or a zero, then transform that zero, transform that special character, transform that whatever value that represents a missing value, transform it into NA and impute them if you want to keep them. I mean, is it clear?
Okay, thank you.
You're welcome. Any other questions, concerns about this?
So Mo, you said first replace it with NA and then impute it.
Yes, if you have a special character or a zero in there.
Okay, so first NA,
And
so
you,
then
you didn't have
program.
you didn't have to do that. You didn't have to. You could simply do replace whatever special character with with a main with a constant. I mean, but this is one way to do it. First, replace with an NA. If you were to keep them, I would do replace the special character with an NA and impute that NA using either mean or mode or mean, mode, median distribution, depends on the type of the data you are dealing with. Okay?
Okay, thank you.
You're welcome.
So, brother Mo, so when you say impute, you just mean to replace those NAs with the mean, right?
Yeah, but you have to calculate the mean. That is what the imputation means. Calculate the mean first. When you calculate the mean, of course, you are going to calculate the mean of all the non-empty cells of the column. then you are going to replace the missing values with the mean calculated. That is what we call imputation.
Okay, thank you.
You're welcome. Yeah, when it comes to missing values, of course there are other methods you could use. You could split our data into let's say that you have a column that is age, and you have a huge, you got 50% empty cells. You got 50% empty cells. So of course you could something like this. Of course you could split on that variable. We are going to split on that variable, and we are going to use that variable as a target variable to predict using machine learning. So we could do that. Okay, we could try a machine learning k-nearest neighbor. So but this is way beyond the program, so I'm going to skip. So of course there are other methods, some of them that I did not include everything, every step that you could use to handle missing values, but two of them, this two here is enough probably. So one of them is simply drop if there is no value in them, or they have too few records to worry about. You could do imputation, and also you could do using machine learning. That is how we in general we could handle missing values if you have any. The second problem that we learned about is finding the outliers. As I said, outliers definitely create a lot of statistical problems if they are not handled properly. So there are a lot of techniques that we could use to extract, to determine these outliers. One of them is using the grab test. Yeah, grab test simply calculates. For the grab test, we will be looking into the p-value. Yeah, grabs test. You import. You need to install Outliers as a package, and from this package here, we import the method, and we name it as grabs. Then you pass to it data. In our case here, we pass to it the age. So let's take a look. Unfortunately, this is not what I was expecting. I was expecting to see a p-value. I believe if we were to do a test, I simply want to try something. I don't know if it's going to work. Summary. No, this graph. This is not what I'm looking for. I'm looking for the p-value. It's simply with the graph test. It does show you, it calculates the probability value or p-value, and if the p-value is greater than 0.05, it simply means there is no outliers, and if it's less than 0.05, it simply means you have an outlier. So I'm gonna show you how this graph test works in R. A few things that you need to be aware of. If you have an outlier in your data and you did not handle it properly, the outlier, it could be one, it could be multiple outliers. They will definitely distort your statistics. So the position of your data could be misleading, and also it could distort the relationship between your elements, between your data elements. It could mislead the result, and also you might not be able to generalize well. So that is some of the reasons why we have some of the possible reasons why we have to handle missing values. So to determine the outliers, the graph test is what I was talking about, but this is for R, and I was expecting to see this type of information. I simply need to look into the code. You see it does look into the entire set, entire elements, in a graph test, and pass into it your feature, and of course it will calculate the p-value. So if the p-value is less than 0.005, which is the threshold, means that is a sign that you have an outlier in your data. And also it does tell you the element that thinks it's an outlier. So this is what I was expecting from this code, but for a reason I might be simply not coding it right. So graph test, looking for the back of the age, and I was expecting to see the statistical. You see the the result in terms of p-value, but for a reason, it's so it says here 98 is an outlier. 98 is an outlier based on the functions we created. 98. And if you were to look into, if you were to sort our age into in descending order, from the largest to smallest, we got 298. Okay, I still need to fix this, but anyway, part of this grabs test is working. I will go through the codes. I will go through the codes and explain them. We'll explain them next session. Okay, so yes, graph test. Graph test is one method to simply help us detect if there is an outlier. And as I said, an outlier, it could be an anomaly, it could be a typo, it could be a real value. And the easiest way to handle outliers, determine outliers, is simply use a scatter plot. If we were to use a scatter plot, or use a box plot, use a visualization in general. So let's take a look into. We are going to create a box plot of the age, and I believe we already learned box plot in data visualization. So anything that lives outside the whiskers, anything that lives outside the minimum, this is minimum whisker and maximum whisker, and we get here your 25%, your 50%, your 75%. Anything that lives outside the minimum whisker or the maximum whisker is an outlier. So we got a lot of outliers in the age only, and you could do that for any single, for other variable, one at a time. Okay, again, when we are talking about the talking about the statistical, the 5-number sum of age, get here, this is this for D. we got 10 in here. I'm sorry, yeah, we got the 40. We got, I'm sorry, this is 32. This is 38. This is 47. And of course, we got an outliers, anything that above the whisker. Okay, we could also create the IQR, the quartile, for we could eliminate an outliers by calculating the IQR score. Import the packages again, and let's take a look into. We could also use the QQ plot, a quantile plot. So the quantile plot, what it does, it simply compares a feature or column. So this is age, the blue is age, and the red is its normality. So the red is normal. So it's comparing age with, I mean, with this normality. As you see here, we got a lot of problems in there. Yeah, we got a lot of probably problems in there, and we got some outliers, few outliers in there. So simply this QQ plot tells us that the age is not ready for analysis. So we have to handle it in a way or another. One way is to eliminate. Yeah, one way is to eliminate anything that is above the whisker. To do that, we are going to create the IQR. So the IQR is simply the first quartile minus I'm sorry, the third quartile, or 75% of your data minus your 25% of your data is 15. In other words, it's 47 minus 32. So it should be 15. And the quartile or the outlier is anything above 1.5. Is above the max
of the duration.
Address, go ahead and mute yourself, please. So the quartile is anything, I mean, the outliers, either positive or negative outliers, they are anything that is with the maximum whisker multiplied by 1.5. So let's determine. So we got here 2. Anything that is below 9.5 is an outlier, and anything that is above 69.5 is an outlier. So all these animals in here, yeah, all these you see the dots in here, they are above 69.5, and anything that is below 9.5 is an outlier, but luckily we don't have any. So let's take a look into the data. 69.5. So these two are going to be an outlier. So let's remove them. Simply remove them, and now so we removed them. I removed anything that is not above the IQR multiplied by 1.5. No, I'm sorry, the third, the 75% times 1.5 of the IQR. IQR is 15, and anything that is the 25% times minus 1.5 multiplied by IQR. So this is what this code is doing. So give me anything that is not less then lower whisker, and not in anything that, and or higher than upper whisker, and eliminate them. So now this is the box plot of the age with the outliers removed. Okay, so so this is the original. We got a lot of outliers in there, and after we calculated all the elements that they are above or below the max whisker and lower whisker, we eliminate them. Now we got a very good to go elements. Of course, we deleted a lot. So if you determined if deletion is one option, this is one way to do it. Of course, you could use z-score also to determine if you have a missing value. So z-score is a statistical methodology or method that you could use, and the z-score is simply the any value when you apply the z-score on a variable. So we are going to do here a z-score on age. If you have anything below 3, -3 or above 3 is an outlier. Anything below -3, so yeah, we got one outlier in there. Definitely anything, if you have a value below -3 or above 3, it simply tells you that you have an outlier. Okay, any question, concerns about the how to handle outliers and missing values?
So Mo, I saw some of these values are coded as 0.75, 0.25. Can they be changed? Why they left it like that?
Point one, so can you say?
Yeah, quartile 0.25, quartile 0.75 up there, and 1.5. Are those values supposed to be
where
changed if you want to, or
where do you see them? This
all? No. If you scroll up, please. Yeah, these 1.5 time IQR, and then all these quartile 0.25, 0.75. So we're not supposed to change those. We should use these numbers as is.
yes, as is, yes. But
Okay.
you need to calculate the IQR first. IQR changes with the data. So, but the formula is the same. You keep the formula as is. Simply, if you were to do for example, let's say you want to do it. You want to do it for duration. Okay, simply change the age to duration and play around it. Let's try it here first. Yeah, we got here. Yeah, 49118 is an outlier. So you got an outlier there. And let's take a look into the box plot. So you got a lot of outliers in there. Let's take a look into descriptive analytics. We got here the minimum is 0. This could be an outlier. This is 0. I really don't like the 0. And the maximum is almost 5,000. So we need to determine if this is a true value. And if we were to use the QQ plot of duration, you are going to see a very strange. That's what I was expecting. So we got a lot of. You see here the tail is too far from the normal distribution, and the left tail, the right tail is too far from the normal distribution. So we need to handle. Yeah, if we were to use this duration, we need to handle this part in here. So we need to probably delete. There are delete, and the remaining we have to scale. or we have to transform. We could use log transformation or inverse transformation. It depends on the type of skewness that we are going to learn next week. So let's take a look into the box plot, into the IQR. So we are going to calculate the IQR first.
Mo, can I ask one question?
Yes, sir.
So those two outliers in duration graph that you said we need to delete, how do we get to know which one?
That's what I'm trying to do here. So the IQR is to 17. Now we are going to calculate the lowercase, the uppercase or upper fence and lower fence. So we got minus 223 and 644. And now let's look into, let's delete them. So by default, we calculate, we determine these outliers by simply calculating the how far they are from the higher or the max whisker, and how far they are from the minimum whisker. Let's eliminate them, and now we take a look into duration. Yeah, now I'm making a copy of my data. And now let's take a look into. So we should have we should have a better box plot of we should have a better box plot of the duration. Let's take a look. Yeah, it's still better, and of course you might not get rid of everything, but it's better than this. This is way very bad. Okay, so the code is there. Simply change the variable to whatever variable that change the variable name to the variable of the column you're trying to determine. Okay, so next week we are going to learn how to transform some of these. We are going to learn how to transform the skewness, and also we are going to learn how to transform the categorical into numeric. And we should be done with most of the data preparation, data preprocessing, and by the end of next week we should have a final version of the data that we are ready to use in our modeling. So we are going to have a final version that we are going to use for our modeling. So we should have a version number 4, and this is the version we are going to use for the modeling. Okay, folks, that's it for today. Thank you for joining the session, and thank you for being part of the program. I'll talk to you next week. Until then, you guys have a great weekend and great weekdays coming soon. Assalamu alaikum.
Thanks, Mo.
Bye, everybody.
Assalam.
Thanks, Mo.
You're welcome.